Welcome to another IBC. My name is Mo Goyal. I'm the Director of Product Marketing at Evertz. We're again excited to be participating in IBC and highlighting some of the new technologies that we're focusing on. For the most part, our focus for this show is software-defined video networking, SDVN. And this is a solution that we've been working on for about 2 to 3 years, but has started to get a lot of market traction over the last 6 to 8 months. Technology that we were showcasing at NEB to now has gained a lot of traction, not only in the North American market, but now internationally, as customers realize that there is a big transition happening in the industry today, moving away from an SDI architecture to something that's focused on 10 gig, 100 gig interfacing over IP, using IP. This is the architecture we're highlighting as the core for any facilities that's being built today. In fact, we've delivered this to 3 or 4 large customers. In fact, one of them is on air with this technology. So they have gone from the traditional SDI mode to a facility that's purely based on 10 gig Ethernet in the core and doing live sports production with it. So as we see the acceptance of now going from SDI to 10 gig, we're now seeing, okay, what are the solutions? What are the challenges? And what are the reasons to use it? Well, first and foremost, we have this concern that if we move into IP, we move into this 10 gig world, that we're going to have to re-educate ourselves. We're going to have to change our knowledge from that traditional SDI mentality in video to something that now is IT-centric. And there's a lot of concerns about that. One of the key elements of our SDVN solution is that we're maintaining that control, that interfacing to the system that our operators are used to today, in that simple mindset or that simple philosophy of keeping source and destination. I want that source, that destination, take. I don't have to go into the interface to program an IP address, go into the switch to configure some routing information to make that happen. I've abstracted that away using our controller, and we've now presented an interface that is common to what they have used today. So an operator would step up to a control panel that they already use today over an SDI network, now can be switching video over an IP network seamlessly without knowing the fact that they're actually going over an IP network. So we've alleviated the concerns within the actual operations environment that we're going to have to learn something new, there's going to be a lot of training. In this aspect, there isn't. It's the same philosophy. We don't need to complicate it. It's a system that's working for years. Why change it? The other key element of our SDVN solution is we're leveraging 10 gig, 100 gig interfacing. Okay. And one of the things that allows us to do is with 10 gig Ethernet, we're able to carry uncompressed video, 6 uncompressed HD signals over a single 10 gig link, and compressed video over that same link as well. So in our current operations, we have an SDI architecture, which is going to typically be a core router that's handling our production environment and such. But on the edges, on the peripherals, we have IP networking that's handling our transport streams between point A and point B. With this architecture, I can put them together in the same infrastructure and manage them the same way I would with my traditional SDI. I want that stream to that location, that source to that destination, take. Okay. It allows us to really now be format agnostic. Biggest challenge with the facility today is that formats are coming quickly to market. It was a long time between SD to HD, a shorter period between HD and 3G. We're now talking Ultra HD 4K, which is 12 gigabits per second of bandwidth after I carry uncompressed. And we're also now talking about Ultra HD 8K, 48 gigabits per second, coming within the next 6 years. So for a facility that is looking to build today or looking at their architecture has to understand, well, I can't continually change my SDI core. What do I have available today? It's 3 gig SDI, 6 gig SDI, Am I going to wait for 12 gig, which means I have to change my router, I have to change all these other elements? 10 gig gives me that flexibility to be format agnostic, not only for compressed, but uncompressed. SD, HD, 3G, Ultra HD 4K, Ultra HD 8K can all be carried over this 10 gig Ethernet very easily. So I remove the concerns about, is my facility ready for the next format? The other element is we're also SMPTE compliant. This is not technology that is in-house created, non-standard. It's leveraging SMPTE 22-5, 2022-5, and 2022-6 as the interfacing to carry uncompressed video over 10 gig architectures. By moving into this whole 10 gig core, we also changed the way a facility is designed and how you actually use resources. One of the challenges that facilities have is that in reality, a lot of the devices that they may have in their current SDI core or SDI facility aren't used 100% of the time. For example, let's go back to a production control room where the elements in the actual control room is you have display walls. Those display walls are being fed by multiviewers. Those multiviewers hang off the core router. Now, if I'm doing a production, I may be using that room 2 or 3 hours a day at the most. The other 20 hours is left idle. I have hardware that's left idle for those other parts of the day. By going to this 10 gig core, I remove this whole concerns that customers have about limitations in I/O. With our packet switches that we have, you have a large capacity to carry number of video signals. Using our EXC platform, which we'll highlight shortly, you can carry 13,800 uncompressed video signals, HD, across a single 40RU chassis. No longer concerned about I/O. So everything goes to this core, which means everything's available to the operator. If they need an up converter, grab that up converter. If they need a frame sync, grab that frame sync. Free it up. So better utilization of the hardware, no longer concerns about adding services in terms of what effort I need to put in, how I have to patch a router. I can launch services faster and quicker. And it's all based on, software-defined networking, which is a philosophy where what we're doing is we're separating the control plane and the data plane. In our traditional network switches today, you have control plane and data plane residing on the actual devices themselves, which means you get a local view of your network. You have a very localized view of where I got to move packets. In our architecture SDVN, designed for video, what we've done is we've basically taken the control plane, separated it out, and made a very fast, high bandwidth switching platform that's just strictly a forwarding engine. And what that allows us to do is now make intelligent decisions based on the entire network, the entire view, and picking the best path, the most efficient path to send packets from point A to point B. And in fact, we're leveraging Magnum, which is our control system, what we find in traditional SDI world already. We're not introducing anything new in terms of a whole new philosophy. Magnum does that already today. If I look at my traditional SDI system, our routers are dumb switches. The facility controller, Magnum, is the intelligence. It makes the decision, what do I need to get from point A to point B? And we're taking that same philosophy, except replacing the SDI core with a 10 gig core. And what happens here is that you have a SDN controller or SDVN controller orchestration layer at the top there with Magnum. And in the middle, a large packet switching fabric and tying in all these different services together. So some of the elements that we have, we introduced at NEB our 40RU 2304 port 10 gig packet switch, 46 terabits of switching capacity. At IBC, we're introducing our smaller version of that, the EXE VSR 28. So you have 1152 ports of 10 gig Ethernet in a 28RU chassis, which gives you the capacity of 23 terabits of switching, which is the equivalent of 6,900 uncompressed HD video signals in and out in a 28RU. Okay, 10 times the capacity of anything that's out there today. We have also smaller switching fabrics to complement our package here. So this is going to allow us to bring in smaller facilities or aggregation points. The other elements is this bridging of the SDI world to the 10 gig. How do I get into the 10 gig world? Well, we have different gateway cards. We have our uncompressed gateway card, which will take uncompressed HDA, 3 gig SD signals, using SMPTE 22-5 or 6 and 6 to move it over a 10 gig link. We also have compressed versions where we use JPEG 2000 to get higher number of signals through that same 10 gig core. So leveraging 10:1 ratios over that single 10 gig link, I can carry 60 HD signals using JPEG 2000 over that link. Making its debut at the show this year is our high density SDI gateway card. So finding ways to cost effectively allow our customers to migrate from SDI worlds to that 10 gig core. And the 570 allows that to happen. Another complementary product here is our ASI gateway card. This allows us to take existing ASI signals, map it to a 10 gig or IP interface, switch those streams across. Series of encoders feeding into the IP core. We have also our distribution. So everything that is now connecting to this core is all over IP. So our 3480 is our main screen encoder as well as your ABR. So you're not only delivering your main H264 or MPEG-2 stream for your traditional linear path, you're also now deriving the profiles you require for your OTT, web-based services and such from the same platform. One of the other key elements is the multiviewer. We have our J2K multiviewer that we introduced at NAB. For IBC, we're introducing the uncompressed version. Again, 10 gig in, signals come in, generate the actual mosaic, and we fire it back over IP back into the core. And then we distribute those signals using that core, feeding these devices that connect to the monitors themselves. So essentially you have a virtually limitless multiviewer that you can build within this facility. Other elements, our Dreamcatcher, our replay system can be out device as well. So you can feed your core leveraging 10 gig interfacing. Up, down, cross. This is a video facility. We still need those tools. Frame syncing, up, down, cross, audio embedding, all those elements. We have that. We've provided that on our traditional infrastructure gear, leveraging 10 gig. Playout. The next step after production is playout. Tying in an IP playout device over to RT Live IP. And the other networking tools that allows us to bridge over public IP networks, connecting facilities between or connecting two sites together using the public IP. All being controlled by various software tools, Magnum as the SDN controller, VisLink as our NMS for monitoring and health status, and Mediator is one of the applications we'll talk about a little bit on here for moving content across the SDVN. So we also allow our customers, existing customers, to bridge from traditional SDI to 10 gig, leverage their existing hardware, leveraging their core routers, putting a IP gateway card into the router, which allows them to basically transition from a traditional SDI using our core EQX to an IP with modules that fit into their existing chassis today. Two announcements. One, Cable Deutschland has announced that we're actually putting the press release out today that they have purchased 2 EXEs, fully populated 2,304 ports of 10 gig Ethernet, co-locations within Frankfurt and Munich. And essentially what this does, it allows them to grow beyond their current 1152 squared SDI. What this allows them to do is continue to use SDI for the near future, no longer limited to the 1152 squared. They can go beyond that. But also in the future to migrate away from SDI to carry compressed video signals as well. So they have a combination of 2 core EXEs as well as a number of 570 IPG gateway cards that bring in their SDI into that core. So that's a press release. That's one of the announcements that we were making at the show this week. Another one is a collaboration with Sony. The two companies have been working together, working on IP solutions. Us with our Evertz SDVN, and Sony with its live IP production, designed around a network media interface. The two parties or the two companies will be collaborating together to create a cohesive and interoperable IP architecture, leveraging the technology that Sony has on their cameras, the production switchers, their servers, with the overall Evertz SDVN architecture with EXE and IPX. So this is a relationship that we're excited to participate with at Sony, two industry leaders that are really pushing forward with the IP technology. And we expect to have some great benefits with the partnership or the collaboration that we have. And again, that'll be part of the press package that's available as well. A couple of other technologies that we're going to be presenting is faster than real time. So now that we've got this bigger pipe that we've inserted within the facility, this 10 gig core, how do we leverage that? So what we've done is we started looking at what are the areas that we can accelerate, leverage 10 gig, accelerate the process. Instead of looking at things in SDI or HD speeds, let's look at things at 10 gig speeds. What can we do? What can we execute? Well, we're introducing LiveX. LiveX is our technology, or faster than real-time technology, that allows us, or our customers who are either delivering VOD assets, multi-channel playout, to qualify, look at playlists, qualify content, do QC faster than what they would do traditionally. So they could take a program that would take them, a 1 hour program that comes into the current facility, that would take them 1 hour to ingest, 1 hour to QC, another hour to stream out. They can do that entire process in minutes. So a playout facilities can handle last minute additions faster, they can qualify elements faster. There's a cost savings that become quite apparent to our customers when they see this technology. And we'll be demonstrating that on our booth as well. Like I said, nonlinear video deliverables, basically high throughput content providers. This gives them the ability to reduce the amount of operational interactions with the media. They can do it faster than before. Also, anything that's doing a linear channel look ahead, you can do a QC in 20 minutes rather than waiting a couple hours. So it's a increased number of capabilities that a facility now has, and it affects their bottom line. It's essentially a savings that they have in their bottom line. An example of the auto-confirm playlist rendering, everything is rendered, the entire playlist, not only just the content, the graphics, the DV squeezes, everything is generated, rendered faster than real time. Those are the two key technologies. Try to keep it quick. Apologize for the late start. But really the key message for us this year is SDVN. The announcement with Sony is another validation that the industry is moving towards this technology. With deployments increasing, we are the leaders in 10 gig.